welcome to my channel. Please like, share and subscribe. In this part of the tutorial, I would like to discuss the airflow scenario in an industrial oven. Ovens are used in various industries such as automotive, food processing, petrochemicals, etc. for heating and drying purposes. So in this tutorial, the airflow over a car in oven is presented. In industrial ovens, the number of airflow nozzles, their location, size, flow rate and temperature of air play a predominant role on efficiency of the ovens. Efficient drying and heating processes in minimum time is main objective. In this test study, we study the setup procedure and simulation with simple geometry and with only 2 inlet nozzles. I have created the geometry of oven in SALOME and the car geometry is downloaded from the SimFlow website. The link is given here and I will add this in the description also. So the oven geometry dimensions are given here, that is 3 by 0.7 by 2.2 meters. I have scaled down the car geometry to enable the simulation in SimFlow evaluation version. So the case setup is done in SimFlow GUI and the CFD solver used with OpenFoam, and post processing is done in ParaView. Let's start first the creation of oven geometry in SALOME. So the scale geometry is loaded here. Now I create a box around it. So the box dimensions are 3 meters in x direction, 0.7 meters in y direction and 2.2. Okay. So now we try to transform the box so that the car exactly fits within the box. So operations, transformation, translate, select the box, then in x direction we translate by minus 0.8, in y direction translate by minus 0.1 and in z direction minus 1.1. Apply and close. So now the box is fixed. Now the geometry, the car geometry is within the box. So we can see this. Change the color. To make it transparent. So this is the position of car within the box. Now let us create the inlet nozzles. I would like to create 2 nozzles on either sides. So first let us explode the geometry into faces. Explode. Translation to faces. Apply. So now select all the faces and convert into compound. Okay. Now we have compound here. Now let us create a circular disc of radius 0.1 in y direction. You can see the orientation of the disc in this direction. This is what we want. Okay, apply and close. Now transform this disc to one of the sides. Translate disc. Let us translate in x direction by 1 and in one direction, y direction to 5. Minus 1.1. So this is the point. Apply and close. So we have an inlet placed here. Then we need to create another inlet on this side. So let's translate again this translation to object in z direction by 2.2 meters. So now it is created here also. Okay, so we have two inlets. Fine, let us name this as inlet 1, inlet 2. Okay, now we have to cut these two surfaces from this compound. So select the compound, operation, boolean operation, cut. Two objects, apply. Okay, now you can see a cut is created here in the other sides. Now our geometry is done, so we will rename them. So this is what we do is now add these two inlets here. So this is a compound. So this compound 2 is oven, and we have all the three: oven, inlet 1 and inlet 2. Now let's save this geometry. Okay, now though I am saving these files inlet 1 and inlet 2, there is no need to use in the case setup. I'll show you. Now we have completed the geometry creation in SALOME. Now let's start processing the case in SimFlow. So we will go to new, oven simulation, create. Now the new window is opened. Now here we go and load the geometry. So I have loaded the car geometry. It will take some time, so let us wait. So the car geometry is loaded. Now we will load the oven geometry. Yes, so it is loaded. Okay. Now here, this is the geometry. Now we create the boundary surfaces. So these are the boundary faces of the car, and we will define this as wall, so no need to touch this as of now. We go to oven, and there are the 8 faces, so we will select each face. Now first we select the inlet. Now again the same procedure as I described earlier. Press Ctrl key and select the face, then release the control key, press this field and press escape. So the first group is created. Then let's create the second one the same way. The second group is created. Now create the surface. This surface has one boundary here. Okay. Then rest of the faces will be defined as one wall. So select this one. Okay. Excluding this inlet and outlet faces, we have selected all sides and we define one group. So now you can see here the default is empty, all the groups are created. Now let us check this. So this is the car. And the oven is in this direction. So now let us define this group, that is this one as inlet 1, rename it as inlet 1. Group 2, rename it as inlet 2. Now group 3 is, so here it is treated as outlet. Outlet 1. This one. Outlet 2. And all 4 are walls. The face groups are created. Now we keep this car face group as a single default group. So now the groups are created. Now we go to hex machine. Okay, so we'll take here, because we are using the SimFlow limited evaluation version, we cannot refine it further much. So I use only one layer here and I don't touch this. Now go to oven. So here too I will just use only one. Now that is done. No need to touch anything here. Then we go to base. Now once the base is created here, we have to just click the auto size. So it takes the size of the outer domain. Now this is done. Now the cells, we have a limitation here, so I go with 60 cells in 60 divisions in X direction, 40, 40. Okay, then here we are defining all these. We no need to touch here now. So this is done. Now go to point. Now here we need to create mesh outside the car, and inside the car there should not be any mesh. So we keep the point in the domain and outside the car. So I think presently it is in the safe location, but we'll just try to keep this further -1. So let us see where it goes. It's coming totally outside, so we'll take 0.5 -0.5, so it is inside, and in all directions you can see it is inside the box, and so it's not within the car. If this point is within the car, then the mesh will be created within the car, but we don't need that. We want to create the mesh outside the car, so we keep the point outside the car. Okay, so now go to mesh. We can use only serial, and it's not possible to run the case in parallel mode. So serial, and then we'll go to mesh. Let us see if with the given divisions the mesh will be created or not, or otherwise we have to reduce the cells. So now press the mesh button. So the meshing has started. So you can see a window here. So now it is progressing. We'll wait. till the mesh is created. Okay, so luckily the mesh could be generated. There is no pop-up here that these node numbers are higher than the limitation, so we are on the safe side. Okay, now the meshing is done. I would like to bring a special note here. Generally in aerodynamic simulations, like the object is placed in a tunnel, like a car placed in a tunnel. So in that scenario, this surface will be an inlet where the flow air will be flown in this direction and outlet will be in this direction. This is in general aerodynamic simulations. But here in oven simulations, the inlet nozzles are placed on the sides and top of the oven geometry depending on the design. So in this scenario, these inlets will be the sources from where the hot air will be blown. Now the car geometry in automotive industry, the car geometry will pass through this tunnel. So this surface and the other side, these two surfaces should be open boundaries. So that is the reason why I created this geometry in SALOME with inlets here. Otherwise, if it is an aerodynamic simulation, we can directly create this geometry in SimFlow itself, because we take this surface as inlet and the other one as outlet. So but here in oven simulation, where the inlets are at different locations, multiple locations, so I created the geometry of the oven in SALOME and imported here. This is a special note. Okay, so now the geometry is created, a meshing is created. Let us check how to see this. So we can check here the car geometry. When we click geometry, yeah. So in the geometry mode, so you can see the geometry here. If you want the mesh mode, you can click this, so you can see the mesh. Right. So we'll continue in the mesh mode now. Then let us see how the inner geometry is created. We'll cut a section here. Okay. So now I create this section, so you can see the car is cut here. Yeah, meshing is not so good because we need very fine mesh near the geometry, but due to the limitations in our version, I could not create much better geometry here. But nevertheless, the objective is to set up the case and present the method of simulating this kind of simulations using OpenFoam. So when we set up the case directly using the OpenFoam, like Windows subsystem, there we can refine the mesh in this in the vicinity of the car, so that we will get much accurate results. Okay, so we close this. Now the geometry is ready. Now we go to, now here we need to change all these things. So first of all, the car's scale. So here we define it as wall only. We'll keep it like this. All the flow boundaries should be set as patch, inlet 2, patch, outlet 1, outlet 2. And again this is a wall, so I said we are keeping it as a wall only. Now the meshing is done, so we go to setup here. So oven simulations are generally transient, so we take transient simulation and incompressible. So I use ICO. So the ICOFoam simple transient incompressible solver for laminar flow of Newtonian fluids. So I take here laminar, but generally we can go with turbulent also. Okay, so the solver is selected. Then we go to transport properties, material, air is selected as the fluid. Then no need to touch this for this case. We go to boundary conditions. Yeah, so car scale is wall, no need to touch this. Now oven is inlet 1, so we need to change this as velocity inlet. So it's surface normal fixed value, and I use 0. Let us take 5. And okay, then this is also inlet velocity 0.5. okay, so outlet, this is pressure outlet, and this also is pressure outlet. No need to touch these values. Initialization is done automatically. Then we'll put some monitors. So go to sampling and select this. I want to create a geometry here in this direction. Okay. Okay. So this is the cut we will be getting. Okay, fine. Okay. So we need pressure. Okay, if suppose we want the turbulent parameters also, then we can go back here and add turbulence as well. Okay, now here in this simulation let us not add this. Okay, now in monitors I added the phase, pressure and U. Okay, then we will go to run. So transient mode, the simulation time I'm taking for generally the simulations are run for oven for 5 minutes, 10 minutes like that. So I will take it for 3 minutes, that is 180 seconds. Yeah, or it can be, let us go with 180 seconds. Then time stepping is fixed, so delta t I will take very less value. Okay, now this is done, so let us save the case. Done. So here output intervals I will take it every 1 second. This is fine. And here I don't want to clean the old results because I want to create some animation, so I'll keep all the results for time being. CPU, I have only option to select serial, so that is done. So save the case. Now you can see here evaluation version, run the simulation only on one CPU. Okay, so I'll launch the case now. Here I'll try to keep this in geometry mode. Okay. The slicing is not done. It's okay, no worries. This one, yeah. So now you can see we'll keep this in the geometry mode only. Right. Then we'll launch the simulation now. So let us see this progress initially. Okay, now the case is running. The residuals are initially rising, but then it drop. But because this is a transient simulation and the car is placed in the domain, so some fluctuations might be there, and the residuals may not drop too low. But let us see. So let us wait to the final result, and then I will present the post-processing. So the calculations are finished, and it has taken more than 3 hours to run the simulation for 180 seconds. So now these are the residuals. The residual values are well below 1 e⁻⁴. And we can see here the results. So let us plot the result on a section and see. Here just comment this geometry. Now you can see the contour plot over the car. Of course here you can see some patches. This is because the mesh is bad, it is very coarse. We need to refine the mesh so that we'll have a very smooth contour over the car. Okay, so we can play it here itself. You can see an animation, you can see the behavior. Well, after some time it has nearly stabilized. So this is the contour plot. Further post processing can be done using ParaView. So we can load the results in ParaView here. So you can see the domain is loaded. And create a section here. So let us see on this section once. So remove the plane. These are the two inlets from the air is coming in and air flows out in these directions. So let me select air. Okay, now using this ParaView we can make all the animations which we need. I will not explain this further. I will show the animations which I created directly. So the results are plotted in ParaView. I extracted some contours and streamlines. So I am plotting here. So you can see here this is the horizontal section and the vertical section, and at the same time I extracted the streamlines and I plotted here. Let's see the animation. You can see the flow is coming in from two inlets on either sides and hitting the car, and the flow is distributing. You can see from here the streamlines. So further more results can be extracted as required. As I told you, the mesh is a bit coarser. It has to be further refined. That is one modification to be done, and otherwise everything is perfect. So in this tutorial I discussed only the airflow scenario in the industrial oven. For demo purpose I used only two inlet nozzles. Further, the heat transfer is not modeled. In the coming videos I will add conjugate heat transfer and heating of car. So thank you for watching my videos. Thank you very much. Please do like, share and subscribe. If you have any doubts, please comment in the comment section. I will try to reply. Thank you.